Hi guys, let's look at this question where the siren of a train moving at a constant speed along a straight horizontal track emits sound with constant frequency. A detector placed next to the track records the frequency of the sound waves, and the results are obtained or shown here below. Okay. 6.1. State the Doppler effect in words. All right. The Doppler effect is the change in frequency or pitch of the sound detected by a listener because the source and the listener have different velocities relative to the medium of propagation. Or you could say something like, it's an apparent change in detected frequency or pitch as a result of the relative motion between a source and an observer/listener. So any should be fine. 6.2. Does the detector record the frequency of 3,148 Hz when the train moves towards the detector or away from the detector? Definitely towards the detector. 6.3. Calculate the speed of the train. Take the speed of sound of air as 340 meters per second. All right, so we are going to use our trusty little formula here. I'm going to jot it down for you on the side. So please jot down your formula because you do get 1 mark for it, guys. That could be the difference between 50% or 80%. So just jot down that formulas. All right. So they have given us the frequency, right, which is 3148. Okay. They've also given us the speed of sound in air. The listener has no speed. Speed of sound in air is the same here. But we want the source, the speed of the train, which is the source. All right. So we do our little math calculations and we find that the speed of the train is 70 meters per second. You could have also used 2073 instead of 3148. Either is fine. 6.4. The detector started recording the frequency of the moving train siren when the train was 350 meters away. Calculate time t1 that's indicated on the graph. All right, so we can use our little triangle, distance, speed, and time. So therefore, 6.4, we can calculate our time to be distance over velocity. In this case, it won't be d, we'll make it an x. We want v. It's the same thing, but just because it is this question, we'd rather say time and x over velocity. All right. So they have given us the distance, which is 350 meters. All right. We have now calculated the speed of the train, which is 70 right there. So now 350 divided by 70, jot it into the calculator, and you get T1 to be 5 seconds. And that's it, guys. See ya.